Good afternoon. My name is Heran Chun from Korea University. The topic of my presentation today is different cosmetic formulations can induce distinct neural substrates. Cosmetic products have a variety of formulations. Some formulations cause positive feelings such as softness and moistness, while others cause negative feelings of stickiness or grittiness. Traditionally, questionnaires and surveys were used to measure the emotions evoked when applying cosmetics. However, this method cannot capture a real-time response for emotions and can be flawed by the respondent's incorrect remembrance. For this reason, researchers proposed a new method using neurophysiological data to measure emotions. By using neurophysiological measures, it is possible to acquire more objective and quantifiable emotion-related data while using cosmetics. The purpose of this study was to compare the emotions evoked by the application of different cosmetic formulations using EEG and to classify the emotions using EEG features based on machine learning technique. 5 subjects participated in this study, and 3 different formulations were used, including 2 positive formulations and 1 negative formulation. Each of the formulations was repeatedly applied 3 times in a random order. After applying each formulation using a pipette, a 10-second baseline was given, and then the subjects were instructed to apply the formulation for 20 seconds using the right hand. The EEG data were acquired with 20 dry electrodes attached on the scalp according to International 1020 system. The raw EEG data were bandpass filtered and then epoched based on the onset of the hand-apply period. Independent component analysis was applied to the epoch data to remove physiological artifacts. We performed event-related spectral perturbation analysis to investigate event-related desynchronization to confirm the distinct ERD-ERS between the different formulations. Classification of each formulation was performed for each frequency band using mean ERD-ERS values as features. Data augmentation and normalization were performed to increase the number of samples and reduce the variation between subjects. Support vector machine model was used as a classifier and feature score for feature selection. The figure shows the difference of mean ERD-ERS values between positive and negative formulations for 6 frequency bands when applying each formulation. The negative formulation showed relatively stronger ERD compared to the positive formulation in general, but significant difference between formulations was not observed. The figure shows the average classification result with respect to the number of features. Overall, the beta band showed the highest classification accuracy, and in particular, the highest accuracy of 71.84% was observed when using 6 features selected by feature score in beta frequency band. In this study, we investigated the differences in EEG when different types of formulations were applied to the skin. As a result, the negative formulation showed relatively stronger ERD patterns, and the highest classification accuracy of 71.84% was shown, demonstrating the feasibility of decoding emotions induced by different formulations using EEG. In the future work, we attempt to acquire sufficient data in order to increase classification performance with more advanced classification algorithms such as deep learning. Thank you very much for your listening. If you have any questions, please post a reply and I will answer them.